When tapping service feeders ahead of the main disconnect for indicator lights, several factors must be considered to ensure code compliance and safety. The primary question is whether these lights and their associated junction box constitute a separate service requiring independent grounding. According to the National Electrical Code, or NEC, a service is defined as the conductors and equipment for delivering electric power from the serving utility to the wiring system of the premises served. Given that the indicator lights are a load derived from the utility feed and are intended to provide operational status, they are generally considered part of the overall service rather than a separate service. Therefore, a dedicated grounding electrode system might not be required. An equipment grounding conductor, or EG, run from the service panel should be sufficient to comply with code. The equipment grounding conductor provides a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. This ensures that any fault in the indicator light circuit will be quickly cleared, minimizing the risk of electrical shock or fire. It is crucial to size the equipment grounding conductor appropriately based on the size of the ungrounded conductors supplying the indicator lights, following the guidelines in NEC Table 250.122. This table specifies the minimum size of the equipment grounding conductor based on the rating or setting of the overcurrent protective device in the circuit. When tapping the service feeders, it is essential to maintain the integrity and safety of the existing electrical system. The NEC addresses the requirements for tapping conductors in Section 240.21, which outlines the rules for overcurrent protection of tap conductors. Generally, tap conductors must be protected at the point of supply and must not exceed certain length limitations based on their ampacity. However, in the context of service conductors, specific rules apply. Section 230.46 permits splicing or tapping service conductors, but it is crucial to ensure that all connections are made using approved methods and materials. Directly inserting number 12 American wire gauge conductors into the main lugs along with the service feeders raises several concerns. Firstly, the suitability of the lugs for accommodating multiple conductors must be verified. Lugs are typically designed and listed for a specific number and size range of conductors. Attempting to insert more conductors than the lug is designed for can result in a loose connection, leading to overheating, arcing, and potentially a fire hazard. Secondly, the circular mill area of the number 12 American wire gauge tap conductors in relation to the main feeder conductors and the lug's capacity must be considered. Although it's stated that the combined circular mill area is within the lug's maximum rating, the physical compatibility and secureness of the connection remain critical. It's essential to ensure that the smaller number 12 American wire gauge conductors are held firmly in place by the lug alongside the larger service conductors. If the lugs are not specifically listed and labeled for multiple conductors, an alternative method for tapping the service conductors should be employed. One option is to use insulated splice connectors that are designed for tapping conductors. These connectors provide a secure and reliable connection while maintaining the insulation integrity of the conductors. Another option is to install a junction box with appropriately sized terminals or connectors for splicing the tap conductors. This method allows for a more organized and accessible connection point while ensuring compliance with NEC requirements. Regarding the sizing of the tap conductors, the NEC provides guidelines in Section 240.4d for the protection of small conductors. In general, number 12 American wire gauge copper conductors are permitted to be protected by a 20 amp overcurrent device. However, the specific requirements may vary depending on the application and the type of load being served. In the case of indicator lights, which typically draw a relatively small amount of current, a 15 amp overcurrent device may be sufficient to provide adequate protection for the number 12 American wire gauge tap conductors. It is important to verify the ampacity of the conductors and the rating of the overcurrent device to ensure compliance with the NEC. Furthermore, the physical installation of the tap conductors and the junction box must comply with all applicable codes and standards. This includes ensuring that the conductors are properly supported and protected from physical damage, and that the junction box is securely mounted and accessible for inspection and maintenance. The junction box should also be appropriately sized to accommodate the conductors and connectors without overcrowding. Proper labeling of the conductors and equipment is also essential to facilitate future maintenance and troubleshooting. In summary, when tapping service feeders for indicator lights, several key considerations must be addressed to ensure compliance with the NEC and to maintain the safety and reliability of the electrical system. Firstly, determine whether the indicator lights constitute a separate service requiring independent grounding. In most cases, an equipment grounding conductor from the service panel will be sufficient. Secondly, evaluate the suitability of the main lugs for accommodating multiple conductors. If the lugs are not listed for multiple conductors, use alternative methods such as insulated splice connectors or a junction box with appropriately sized terminals. Thirdly, ensure that the tap conductors are properly sized and protected by an appropriate overcurrent device, following the guidelines in NEC section 240.4d. Fourthly, comply with all applicable codes and standards for the physical installation of the tap conductors and the junction box. By carefully considering these factors and adhering to the NEC requirements, it is possible to safely and effectively tap service feeders for indicator lights while maintaining the integrity and reliability of the electrical system. Consulting with a qualified electrical contractor or engineer is always recommended to ensure that the installation meets all applicable codes and standards and is performed in a safe and professional manner.